So you said what 1 to 3 things. So I went for the full 3 because, you know, if you got magic wishes, why squander them?
Exactly.
So I mean, you know, I think the first and obvious would, you know, I would wave my magic wand and eliminate spoofing on the internet. Again, you know, UDP reflection attacks are not super sophisticated, but they are super effective because there's just so many avenues on the internet at large right now to send those spoof packets through. So, you know, I would really wish that, you know, there would be no spoofing on the internet. Now, that said, I don't have a magic wand, so I know that that's not going to happen. So at the very least, I think it would be, it's important to continue to work towards, you know, having large organizations and networks and implement, you know, established anti-spoofing BCPs and other measures. However, you know, at the very least, I think that we can maybe do a better job, both with operators and, you know, or public, you know, government type entities to kind of just look at, have the visibility of where spoofing is occurring. And not necessarily to name and shame, but to, you know, to understand that, you know, this traffic that you rely on is, I don't want to use the word clean, but it's more reliable and stable, and that, you know, you have that kind of understanding of where your traffic is coming from, and then you can choose, or if you so feel to not accept that traffic, right? So I think the visibility, and I think another part to kind of helping get there is that, you know, I would hope that large organizations such as operators start, you know, considering putting in some clauses in their paid pairing arrangements with their upstream providers saying, you know, we expect you to have these kind of standard anti-spoofing mechanisms in place. And if there is a viable reason you cannot, you know, you show me how you're monitoring it. What is our SLA to kind of mitigate that type of traffic? We escalate it to you. So that would be my number 1 wish. So I got 2 wishes left. My number 2 wish would probably be IoT device security something. And I know that there's not a silver bullet there, but you know, be that what we're starting to see with the US passed some legislation where their suppliers of IoT devices had to meet kind of a minimum security standard. So I think that's, you know, a good start to kind of incentivize maybe some of those IoT manufacturers to kind of up their game when it comes to security. Or, you know, I've also seen that there's, you know, end user education, update your router, your internet refrigerator, what have you. Or even like, you know, some of these rating or some sort of colorful sticker rating that, you know, the end consumers can kind of look at or use as guidance when buying these appliances. Because unfortunately, when it comes to, you know, a lot of the UDP amplification attacks that we're seeing, that is by and large a lot of what I'd call residential home users, and they, you know, these are their IP cameras or their media devices or their internet refrigerators. So that's another thing I'd like to see, IoT device security something, because again, I'm not sure what that something is, but obviously we need to do a better job of that. So I think that would be my second wish, is to kind of reduce those low-hanging fruits that are being actively harnessed into, you know, what are devastating attacks in the end for some of these victims, right? So that would definitely be my second wish. And my third wish, and again, this is me speaking as Krista and not for my employer, I would like to see what I just call effective abuse notification to start. I'm not even going to use my wish for like crazy things. I'm just going to say, I'm not even going to say remediation word at this point, but just effective abuse notification to these end users that might have, you know, these vulnerable internet refrigerators or IP cameras. And I'll just add that, you know, at least here in Canada, and I believe in the US as well, like there is legislation regarding copyright notification. So typically the way that works is that operators in Canada here, we're actually legislated to do this by law, and we can suffer fines if we don't do it properly, is we get notifications from rights holders that will be IP based. So we will have to, you know, do an IP-based lookup and then send a notification to this user saying, hey, you were detected downloading this copyrighted content, et cetera, et cetera. And it occurs to me that we can use very much the same mechanisms to provide these notifications about these, you know, vulnerable IoT devices, I'll just call them, these home routers, IP cameras, to do things like simple firmware updates. In many cases, that's all it really takes. And it's just that, you know, the user, they just bought a refrigerator. They weren't really in the business of doing firmware upgrades. And it's simply because they're unaware. So I would really like to see not just operators, but I also think that there's maybe a role for, you know, public space, be that government, to kind of, you know, maybe provide some of those materials that, you know, we do the notification and then point those users to maybe like some government content that can kind of help walk them through how to upgrade their internet refrigerator, what have you. So I think those would be my 3 kind of key wishes. And I didn't go totally crazy with them. I think I kept them mostly realistic. But I also have been trying to get some of action on those 3 items for quite some time. So
what I've seen is the most frequent attacks are utilizing IP spoofing in some way. So this obfuscates the origin of the attack, and it can make the attack appear larger, you know, by doing some sort of amplification strategy. If transit providers all watched for these attacks and employed filters on their problem customers, then this entire class of attack would be eradicated within a few months. So I think, you know, I would really love to pressure transit providers to take action here. That's been sort of my main focus for a few years now. Mm-hmm. Another thing that I would highlight is, you know, once we get rid of those attacks, the remaining stuff is the botnet attacks. And in that case, I would point out that internet connected devices are always a threat, and especially IoT tends to be forgotten. People don't quite realize it's connected to the internet. They're not monitoring it. And so I would love to see, you know, some requirement that all internet connected devices, and especially IoT, should come with a random password by default, not a fixed password by default that is shared across all devices, but unique to the device, and also have auto updates enabled by default. So you shouldn't have to log into your IoT thing and tell it to download that firmware update. The firmware update should be applied automatically, and that would put everyone in a much safer state.
Well, there is no reason whatsoever to allow your customers to be able to spoof traffic. Yes, if you're in the middle of the internet, it's hard to build filters which work correctly, but at the edges of the internet, there's absolutely no reason why you should be seeing IP addresses coming out of your network which are not within your network. Yes, people are multi-homed, but if you do the paperwork right, then you know what IP addresses your customers are entitled to use, and you don't let them use anything else. And basically, it's at the edges we have to secure this, not in the middle. Now, people get very precious about this, and they worry about every single machine which could possibly spoof something. But I don't actually mind if your mail server can spoof packets, because the only people who can log into your mail server are you. I care about your customers. If you are selling services, can your customers spoof traffic? And the answer is they should not be able to, and you should be putting in filters or arranging things in such a way that they just cannot do that.
So selective on the source address validation. You don't have to get everywhere and get the important ones.
It needs to be around the edges, but it needs to be where customers are, not necessarily on every single device. It's the devices which you don't trust. That's where you need to do things. Yes, you have very reliable customers, but trust but verify. Okay. Yes, I'd like to show you this nice chart, because what this chart shows is the number of attacks which we see. In fact, over the period 2016 to 2019, these are reflected amplified UDP attacks, which are hitting our network of sensors. We've got about 80 to 100 sensors scattered around the world, and they act as reflectors. Not for very long. If you send them a lot of packets, they stop reflecting, so they don't actually contribute to the problem. But they reflect a few packets so that people, the bad people, add them to their lists of reflectors to use, and therefore they use our sensors, and we can tell who is being attacked. And if we count the number of attacks over time, then we get a really spiky graph. and if we apply some fancy statistics, then we can model that the trend from one year to the next, because there's always more attacks over Christmas. There's always more attacks over Easter. Easter is not, in fact, the same time every year, so that modeling is a little bit fancy. But basically, we can see a trend over time, and like all graphs on the internet, it goes up and to the right. However, as you can see, there are a number of dips in this graph, and the statistically significant dips, and there's 5 of them, and it turns out that they're all associated with law enforcement activity doing something about booters. Basically, the websites where you can go and you can buy a DDoS attack for a few dollars. The first one right at the left there is when the hack forums booter section was shut down, which meant that the booters couldn't actually advertise their wares because there was nowhere for them to advertise anymore. The next dip is when the people who ran a booter in Israel got arrested, and then various other events through that. The big event right at the right-hand side is when the FBI shut down 8 or so booters just before Christmas 2018. So basically, when law enforcement takes action, then we see a few weeks of less activity. And if there was more in law enforcement action, obviously there'd be fewer booters, and that would be a good thing. Now, the interesting thing is that if we look at this graph, what this graph shows is the number of attacks that are against IP addresses in the United States over a 3-year period, 2016 to 2019. Again, up and to the right, more attacks over time. Very spiky, and that's because of things like Christmas and other events and so forth like that. If we look at this, now most of the people who attack, who use booters and do this sort of attack are playing online games. And because when you start an online game, you're put into a lobby and you play with people who have pretty much the same ping as you, that means you're mainly playing with people from the same country. So if you start cheating at the game by trying to run a denial of service attack against the people you're playing against, and this is very common, then basically the people who are doing attacks against US IP addresses are in the United States. Here's the same graph. We've stretched out the vertical scale a bit because it's a smaller country. These are for the UK, and therefore these are people in the UK mounting attacks against other people in the UK. And if we put these two graphs on top of each other, now this isn't a stack graph, this is just putting them on top of each other, then we can see that basically the graphs look pretty much the same. They go up, they start low, they go up and so forth to the right. But if you look very carefully at this section here, you will see that the UK attacks level out for a 6-month period. At the end of that 6 months, they're in fact very slightly lower than they were at the beginning of that 6 months. And that's interesting. So we asked ourselves, why has the number of attacks in the UK flattened out for 6 months? And the answer is because during that 6-month period, the National Crime Agency, the police in the UK, were running adverts on Google so that if you search for the word booter or stressor, because you were trying to find one of these buy yourself a DDoS attack thing, you're using the search engine to find it, if you search for that, a little advert popped up from the NCA which said booting is illegal. It had some more information you could click through and so forth, but basically that flattened out the demand for attacks in the UK for a 6-month period. And when we discovered that it had this effect, we told the National Crime Agency that their advert had worked, and they were very pleased because they knew that they'd run the advert and a few people had clicked through it, but the fact that it had a real effect and we could measure it made them very, very happy indeed. And in fact, these sort of adverts are now being rolled out in other countries. The Dutch have been trying them, and they're going to be tried elsewhere in Europe this year as well. This is all about telling the young people who play games that buying these DDoS attacks is illegal. So we're flattening out the demand side and trying to reduce the number of attacks which are being done in this way. And in fact, looking back, we think that the other dips which we saw in the graph which I presented first, we think those dips may be because during those periods when the law enforcement had just taken an action or somebody has been sent to prison for running a booter, if you actually search for a booter online, you will see these news articles, and all of the news articles will say this person has been sent to prison because doing booting is illegal, right? So that's the message, and it makes people stop and think as to whether or not they really want to do this attack, because they thought they were just cheating at a game, but now they're learning that what they're doing is against the law, and they could, in principle, go into prison for it.
This is really powerful as a magic wand statement, because it shows that if we take measurement data, academic study, run an experiment, in this case, we can see that there's impact. And then now we can actually, now it's up for the industry and governments working together, and we can actually know the knob to turn to have an impact because of it. So
yes, well, advertising works. Who knew?
I mean, it would be good to have this a kind of some sort of a nice coordinated body to coordinate the response, and that's again not sure how realistic that stuff is, and I mean and then you probably going to be left with less of the distributed denial of service, but more with just denial of service, which is again a lot easier to deal with. Right. But yeah, that ingress validation, it
knocks source address validation knocks out a huge range of attack vectors. Yeah.
Yes, and
absolutely. Then it doesn't make DOS go away. It just makes it easier to track and address.
So number one would be very simple and yet really hard, which probably deserve its own like really good and throughout white paper. But if I was some kind of internet god, I would implement end-to-end hop-by-hop authenticity management for the whole IPv4 and IPv6 address space. And this means we will completely eliminate all the spoof attacks, and so forth and so on. But it's a really, really huge topic. Probably a white paper sometime later this year, if gods are good, if gods of internet are good. Second thing is more practical. So, and it comes from my experience mitigating different kinds of amplification attacks. And you probably remember DNS and NTP and memcache.
Right.
And with DNS and NTP, we as a community did a frankly poor job squashing out this threat vector. And as far as I remember, even in 2 years ago, we've seen DNS AMP attacks exceeding 1 terabit per second. While we definitely have tools and mechanics to squash this vector completely. However, with memcache, we did much better. And the question is why? Probably we learned something with DNS and NTP. We learned to speak to each other and communicate threat vector and importance of this threat vector well. So we haven't seen much of memcache attacks in past few years, which means we as a community did our job well. So what will help us to do this job even better is some kind of global unified legal and communications framework to signal and shut down DDoS threats simultaneously, globally. Because when you are a large network operator and you have to this emergency to filter out specific UDP ports on your backbone, it always comes with the risks of litigations and lawsuits and regulators. And it would be nice if we can, in some kind of community document, propose this unified framework for each and every government. And it's part of a government to adopt it or reject it or modify it. But it would be nice if we will have something that will help us do our work better and safer and faster. Last one will be more practical, and it will be dedicated to the audience. So what I would do, I would suggest that we rethink the way we design our networks, network services, and protocols that these network services are using to make them defendable, to have the infrastructure to support graceful degradation, and especially when you're designing, when you're new at this thing and you design your custom UDP based protocol, please consider showing it to public to criticize on it, because we don't really need more of memcache kind of UDP public services in a public network. So if you're doing that, please consult with specialists.
I think we all get a gimme, because I think pretty much everyone would say if they could, wave a magic wand and have source address validation, ingress source and egress source address validation employed everywhere, that it can be employed to reduce the ability to spoof and to more or less eliminate reflection amplification attacks as well as direct path spoofing attacks. Everybody would say that, right? And in addition to that, I'll say that the single biggest thing that I see that makes networks and applications and platforms very vulnerable to DDoS attacks is that the whole idea of having a strict network access control policy that is customized for whatever is being delivered, just a lot of organizations don't seem to have that. And so it's very easy to use traffic that is very obviously out of profile for whatever's being attacked, to attack it and disrupt it. And furthermore, when there's not a good network access control policy, and network operators, endpoint customers, whatever, are reaching out for help, they can't communicate to the upstream transit provider or the overlay DDoS mitigation provider or just other operators, peers that they're asking to help mitigate the service. They can't communicate what the expected traffic profile is for whatever is being attacked, whether it's a website, a DNS server, SIP PBXs, or just users on eyeball broadband access networks. And so, understanding what that network access control policy should be, being able to communicate it, is very important. And there's actually an RFC that's designed to help with that. It's RFC 8520, which is manufacturer usage specification. And the idea behind this is that it was really intended for like IoT devices, that they'll have like a certificate that it can be accessed in a standard way, so that some upstream device, whether it's a router or some kind of DDoS mitigation system or firewall or what have you, could actually interrogate the device, and it would actually say, these are the ports and protocols that I expect. And so you could then use that to auto-generate network access control policies. And so having that universally deployed on services, things like web servers and DNS servers and all kinds of applications that people use would be very helpful. And then having a way to transmit that to other entities so that they could then build a network access control policy to help shield out of profile traffic, and also give them an idea of what specific countermeasures to use during an attack to protect that service or application or device or whatever it is. And so taking RFC 8520 out to its logical extension, and having it widely deployed and utilized in this way, I think would be very, very useful. And I guess the final thing I'll say on this topic is, there have been a few efforts in the past to work on standardized mechanisms for signaling, remote signaling, to get DDoS assistance. Back in the day, there was COPS. There was a DOS effort, that you and I both spent some time on. And so being able to get one of these efforts through the IETF and to make sure that that the effort retains a tight operational focus, with the idea of having a relatively simple, not overly rococo standard signaling mechanism, so that organizations and ultimately devices can programmatically signal that they are under a DDoS attack and that they need assistance from peers, from upstreams, from mitigation service providers, and so forth, and getting it to the point where it can actually be used operationally and adopted by the operational community, I think would be a very positive thing. I don't think we're there yet. I think that these exercises we've gone through with COPS and with DOTS now have been very educational, but I think that we really need to now have a very, very specific focus and say, we're going to focus on communicating the need for mitigation services, and we're going to keep it simple and then work to get it as widely deployed as possible.